Hi everyone, today we're going to be going over the 2022 AMC 8. I'll be providing solutions as well as the thought process behind each problem. So without further ado, let's get started. Problem 1. The math team designed a logo shaped like a multiplication symbol shown below on a grid of 1-inch squares. We want to know what is the area of the logo in square inches. So because they give us a grid, it makes it a little bit easier to just count the number of squares. We can first count the number of full squares. There's these 4 in the center. And then these outer bits are each half of a square, which we can see because it's connecting the opposite corners of these two squares. So each of these is another half. So we already had 4. And now we're going to be adding how many half squares? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we add 12 half squares. And that's going to be 4 plus 6, which is 10. And so our first answer is 10. Okay, on to problem number 2. We are asked to consider these two operations, star and the diamond. We're asking for the value of 5 diamond 3, then star 6. So we're just going to directly apply the operations that they give us. 5 diamond 3 would be 5 squared minus 3 squared. 5 squared minus, should be 2. And that gives us 16. And that is starred with 6. So we have 16 minus 6 and that entire quantity squared. 16 minus 6 is 10, and then 10 squared is 100. Problem 3. When 3 positive integers a, b, and c are multiplied together, their product is 100. Suppose a less than b less than c. In how many ways can the numbers be chosen? So since a is the smallest number, it's going to be the number that restricts the other numbers the most. That makes it like the best strategy for us to start by looking at the different possibilities of a. First possibility would be if a is equal to 1, and then we'll look at b and c for a equals 1. Possibilities there are 2 times 50, 4, 25, we have 5, 20, and that's it, because we can't use 10 and 10 since b wouldn't be less than c. The only other possibility is a equals 2, and then b would have to be bigger than 2, right? So our first possibility might be 4, but that doesn't work because that's too many factors of 3, since 100 is not a multiple of 2 times 4. So the next possibility would be 2 times 5 times 10. And we actually can't go any bigger than that, so we'll look at the next value of a, which is 4. And that leaves, let's see, b would be equal to 5, and c would equal 5. That doesn't work. So that shows us that a equals 4 doesn't work. And therefore these are the only 4 solutions. And actually once you find these 4 solutions, you can just stop because the answer choices don't have anything bigger than 4. Okay, we have the letter M in the figure below is first reflected over line Q and then over P. What is the resulting image? Okay, so first over Q and then over P. Let's first think about what happens when we reflect over Q. It's essentially, when we reflect over a line, it's the same as folding the paper over that line. And if you imagine folding the paper across this line, the resulting m is going to look something like that. And then we're going to reflect over p. So again, it's sort of like folding the paper over that line. And then we will probably end up with something like that. It's also analogous to sort of like looking at it in a mirror. That's sort of like why it's called reflecting. But that gives us E as the answer. Okay, problem 5. Anna and Bella are celebrating their birthdays together. 5 years ago, when Bella turned 6 years old, she received a newborn kitten as a birthday present. Today, the sum of the ages of the two children and the kitten is 30 years. How many years older than Bella is Anna? So we know that 5 years ago, Bella turned 6. That means that now she's turning 11. And since we're also told that she received a newborn kitten 5 years ago, the kitten is now 5. Since Anna and Bella have the same birthday, we know that Anna is turning 14 right now, because that's the only way for these ages to add up to 30. And we're asking how many years older than Bella is Anna, so 14 minus 11 is 3. So we have our answer of C. We have 3 positive integers equally spaced on a number line. The middle number is 15, and the largest number is 4 times the smallest number. What is the smallest of these 3 numbers? So we have on this number line, the middle is 15. The smallest number, let's say, is x. And the largest number is 4x. And we're told that they're equally spaced. So what that basically means is that if you add up the x and the 4x, you'll get something that's twice as big as the 15, because the average of these two numbers should be equal to 15. So the average of x and 4x is 5x over 2, and that equals 15. What that gives us is x equals 6, and that is the smallest of the numbers. Another way you could have done it is to say 15 minus x equals 4x minus 15. So looking at the differences and setting those two equal to each other. And that might be slightly more intuitive, but you should get the same answer. Problem 7. When the World Wide Web first became popular in the 1990s, download speeds reached a maximum of about 56 kilobits per second. Approximately how many minutes would the download of a 4.2 megabyte song have taken at that speed? Note that there are 8,000 kilobits in a megabyte. So we have how many minutes for a 4.2 megabyte song? So 4.2 megabytes. Now, since there are 8,000 kilobits in a megabyte, we want to know how many kilobits 4.2 megabytes is. Well, we're told that we need to multiply by 8,000. And we're also told that download speeds reach 56 kilobits per second. We're dividing by 56 to find how many kilobits per second, and then we're also going to divide by 60, and that would give us how many kilobits there are per minute. Is that correct? Or did you multiply by 60? Yeah, you multiply by 60, sorry. Yeah, the number of okay, so we have 4.2 times 8,000. That's how many total kilobits we need. Now if we divide by 56 kilobits per second, that tells us how many seconds it would take. So actually, yes, we do need to then divide by 60. And that's how many minutes it would take. And now we need to approximate this. So 4.2 times 8,000 divided by 56 divided by 60. You can approximate this however you want. You can like round 56 to like 50 or 60, round off 4.2 if you want, but you should get a number that is approximately 10. Okay. What is the value of 1/3 times 2/4 times 3/5, etc., all the way up until 20 over 22? So we have a pattern here since the denominator is always 2 greater than the numerator. And so what that means is that if we look at the term 2 after a term, it'll have the same numerator as that term's denominator. And since everything is being multiplied, we can just do some cancellations. The next term would have been 4 over 6, which meaning that we can cancel the 4s, and then the 5s, etc., etc. And then up until the 20s get canceled out. So what we're left with is 1 times 2 over 21 times 22. That's equal to 1 over 231. Number 9. A cup of boiling water, 212 Fahrenheit, is placed to cool in a room whose temperature remains constant at 68 Fahrenheit. Suppose the difference between the water temperature and the room temperature is halved every 5 minutes. What is the water temperature in degrees Fahrenheit after 15 minutes? Okay, so first things first, we need to find the difference between these two. So that would be 212 minus 68, and that would give us 144. We know that this difference is going to be halved every 5 minutes. After 15 minutes, it's going to have halved 3 times. So we're going to divide by 2 cubed, and that gives us 18. So that means that the difference between the water and the room temperature should now be 18 degrees. Since the room temperature is a temperature of a big room compared to just a cup of water, we can assume that the room temperature is staying constant, and it also tells us that in the problem. So now we just need to do 68 plus 18, and we get 86. Problem 10. One sunny day, Ling decided to hike in the mountains. She left at 8, drove at a constant speed of 45 miles per hour, and arrived at the hiking trail at 10. After hiking for 3 hours, she drove home at a constant speed of 60 miles per hour. We want to know which graph best illustrates the distance between the car and house over the course of the trip. So from 8 a.m. to 10 a.m., we're looking for 45 miles per hour. Over 2 hours, that would be a distance of 90 miles. So that's what we're looking for. And we can eliminate any graph that did not travel 90 miles in 2 hours. And that's all of them except A and E. Now we're also told that on the way home, she drove at a constant speed of 60 miles per hour. And so going 60 miles per hour for 90 miles, that would take 1.5 hours, since 90 divided by 60 is 1.5. So we're looking for which of the downward portions took 1.5 hours, and that's the one for E. Problem 11. Henry the donkey has a very long piece of pasta. He takes a number of bites of pasta, each time eating 3 inches of pasta from the middle of one piece. In the end, he has 10 pieces, whose total length is 17. How long was the piece of pasta he started with? So if we just look at one bite of pasta, we know that the total amount of pasta that remains after is going to be 3 fewer inches, but we also know that the number of pieces has increased by 1. That's because we started with 1 piece of pasta, but we ended with just or we ended with 2. We have plus 1 piece, but minus 3 inches. So if in the end he has 10 pieces of pasta, that means that this plus 1 piece happened 9 times since we started with 1. And that also means that we lost 3 inches 9 times, which means we lost 27 inches. Now we still had 17 inches at the end, so the amount that we started with must be the sum of these two, and that's 44. Number 12. The arrows on the 2 spinners shown below are spun. Let the number n equal 10 times the number of spinner A added to the number on spinner B. What is the probability that n is a perfect square number? So here are our 2 spinners. We have 4 possibilities for the first and 4 for the second. So our total number of possibilities is going to be 4 times 4. And obviously this only works since each spinner is equally divided here. Now we need to know which of the possible outcomes results in a square number. So if we start with 5 as our tens place, none of these make a square number. If we start with 6, that does work. We can make 64. 7, we can't make any square numbers. And 8, we can make 81. So that gives us 2 possibilities out of 16, which is 1 and 8. Okay. Problem 13. How many positive integers can fill in the blank in the space below? One positive integer is blank more than twice another, and the sum of the two numbers is 28. So if we let the first number be equal to x, then the second number that we add would be equal to 2x plus the blank, which we can call a. And that's equal to 28. We want to know how many possible a's there are. Well, it's actually severely limited by what x is, since x is multiplied by 3. Now, x can range from anywhere from 1 to 9. It has to be at least 1 so that they're both positive integers, but anything bigger than 9 and a will be a negative number. And that won't work since we need the 2x plus a to be more than twice, right? Not less. So since x can range from 1 to 9, a will find its value accordingly, and that means that there are just 9 values. Number 14, we want to know how many ways can the letters in beekeeper be arranged so that 2 or more e's do not appear together. So we see that there are 5 e's in this word, and then a b, k, p, and r. So the only way to not have 2 e's appear next to each other is to have 5 e's, and then since there's 4 gaps, each of those gaps needs to be filled by a different letter. And there's no other way to do this. So since we have 4 other unique letters, there are 4 possibilities for the first gap, 3 for the next, 2 for the next, and 1 for the next. And we just multiply 4, 3, 2, and 1. We get our answer at 24. Problem 15. Laszlo went online to shop for black pepper and found 30 different black pepper options varying in weight and price, shown in the scatter plot below. In ounces, what is the weight of the pepper that offers the lowest price per ounce? So if we want the lowest price per ounce, that's the lowest y value over x value. And the y over the x, of course, is just the slope. So essentially what we're looking at is if we connected each dot to the origin, which one would be the least steep? And for each weight category, we only need to look at the one that's the cheapest, since there's no way that something that weighs 1 ounce that costs $2 could be lower price per ounce than something that costs like 1.2-ish. So we're really only considering the lowest dot in each category. And in fact, you see these ones that are in the middle, We could actually ignore those because the answer choices don't give us any weights that are not integers. So we only need to look at the ones that are integers. So this first one has a price per ounce of about 1.2. We can just estimate that. This next one, $2 for 2 ounces. That would be a price per ounce of 1. This next one offers 3 ounces for 2.5. So that's a pretty good contender since that's going to be under 1. Let's approximate that with 5/6. That's the same as 2.5 over 3. The next one is under 4, and it gets you 4 ounces, but this gap is much too small for this one to be a better deal than the 3 ounce one, right? If we look at the 5 ounce one, we sort of see the same thing. We're saving about $0.50 on 5 ounces, but we also could have saved $0.50 on 3 ounces. And saving the same amount of money over a smaller weight is going to lead to a lower price per ounce. So that means that 3 is the best deal. Number 16. 4 numbers are written in a row. The average of the first 2 is 11, the average of the middle 2 is 26, and the average of the last 2 is 30. What is the average of the first and last? Since it doesn't give us any like real restrictions on the actual numbers, we can sort of just like pick whatever numbers that we want, and essentially that means that we can, just plug in numbers and like use that to figure it out. However, we could also do it in a way that is a little bit quicker and maybe a little more elegant. We are told that the average of the first 2 is 21, and the average of the last 2 is 30. I'll write the 30 over here. Now, we're also told that the average of the middle 2 is 26. And we want to know the average of the first and last. However, what we know is that the average of the first 2 plus the average of the last 2 is equal to the average of the middle 2 plus the average of the outer ones. And the reason for that is because each of the numbers is accounted for once in that overall average. So essentially all we're looking at now is 21 plus 30 equals 26 plus what? And that what is 25. Okay, 17. If n is an even positive integer, the double factorial notation represents the product of all the even integers from 2 to n. For example, 8 double factorial is 2 times 4 times 6 times 8. We want to know what's the units digit of the following sum, and we're taking the double factorial for all even integers up to 2022. So we're looking at the ones digit. That's a clue because obviously it's not going to be reasonable to calculate all of these, but at 10 factorial or 10 double factorial, we're going to see that the units digit becomes 0. And that's going to be true for the entire rest of the sequence. So all we care about is the first 4 terms, 2, 4, 6, and 8 double factorial. Now we can just calculate the units digit and add them up. 2 double factorial ends in 2, since it's just 2. 4 double factorial is 2 times 4, which is 8. 6 double factorial is 2 times 4 times 6, which is 48. And that would end in 8 as well. There, 8. And 8 double factorial is 2 times 4 times 6 times 8, which ends in 4. So now all we have to do is just add these up, and it's 22, so the units digit is 2. Okay, number 18. The midpoints of the 4 sides of a triangle are -3, 0. Let's draw this on a graph. Actually, let's just draw these points. We don't need the graph, right? -3, 0, 2, 0, 5, 4, and 0, 4. Okay, -3, 0, and 2, 0. Those are easier to draw. And then 5, 4, and 0, 4. So we're looking at something like this. And these are the midpoints of the four sides of a rectangle. We want to know what's the area of that rectangle. So the rectangle looks something like that. Oh. And we could connect the dots here. Okay. We want to know the area of the rectangle, but we also know that the quadrilateral that we get from connecting the midpoints is exactly half the area of the rectangle. And to find the area of this inner parallelogram, we just need to know the base times the height. We know that the bases are both 5 and the height is 4. Since the bottom 2 points had y-coordinate 0 and the top 2 points had y-coordinate 4, the area of the parallelogram is just 5 times 4. To find the area of the rectangle, we just need to multiply by 2 now. So that gives us 40. Problem 19. Mr. Ramos gave a test to his class of 20 students. The dot plot below shows the distribution of test scores. Later, Mr. Ramos discovered that there was a scoring error on one of the questions, and he regraded the tests, awarding some of the students 5 extra points, which increased the median test score to 85. We want to know what is the minimum number of students who received extra points. Note that the median test score equals the average of the 2 scores in the middle if the 20 test scores are arranged in increasing order. So first thing we need to do is figure out how we're going to have a median of 85. And we could just keep these 2 students. If these 2 students are in the middle, then we have no issues. 85 median is preserved. However, right now there's only 5 students to the right of that, and there are 13 on the left. So what we need to do is somehow get 4 students to this side. And the way we would want to do that is, how would we do that? Well, the problem here is that we can only add 5 points. So we can't just like bring people from like 65 to 100, right? But I'm sure there's a way to do this. So we probably cannot keep these students there anymore, right? So we're gonna see what happens. Let's say we move these 2 students over. Then we would have a total of 7 students on this side and 11 students here. Or sorry, 13 still. But if we then move 2 students up to 85, we now have 11 students, and then we would have 2 on the 85. So we would have an 11 to 7 distribution. But that still doesn't work, right? So, how would we do this? I think we could do this using 6 students moves, but that actually is not the answer, because the answer is 4. So we're gonna have to figure out which 4 students we can move to make this work. Let me just find the eraser. One sec. I don't want to do text. Okay, maybe I'll just undo everything. Okay, let's look at this again. We're probably going to need to use the fact that we can like take the average of 80 and 90 to get this average that we want. So we're probably going to need 9 students to the left of 80 and 9 students to the other side. What we can probably do is actually bring some of the 75 students up to 80. Will that work? The problem is that we need 9 students on the 85 plus side, right? So we have 5 students currently at 90 and above, and 7 students at 85 and above. If we moved 2 of the 85s to the right, then we'd have 7 at 90, and they would still all get sort of like cut off as we move in, since the right 9 and the left 9 both don't matter, so to speak. So if we bring some of the 80s to 85, then we have, actually, yeah, this looks like the correct way to do it. We'll bring 4 students from 80 to 85, and now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now we have 11 students who are 85 and above, and we get our answer that we wanted. So the new distribution would be 1, 1, 3, 6, 1, 4, 2, 2. And that would give us the 85 as we wanted. So obviously, like, the challenge in this problem is sort of thinking about, like, at what point do the students sort of not matter anymore? And that would be after the 9th student. That's when we start counting this 2 students for the median. So that means that we don't really like need to move this student up, for example, right? We would never consider that. Okay, problem 20. We want to fill the grid with integers such that the sum of the numbers in each row and column is the same. 4 numbers are missing, and the number x in the lower left is larger than the other 3. What is the smallest possible value of x? If we just try the first row, we see that the sort of like magic sum is 12. And if we look at the bottom row, we see that the sum of these 2 numbers in the left 2 is 4. And since we have a negative 2 here, the sum of the numbers in these 2 is 14. Now this 14 is a lot more restrictive. It basically means that the minimum possible value of x such that x is greater than this would be 8, this would be 6. And that's the minimum possible value of x that works here. Now, does it work everywhere else? Well, 8 plus 8 is 16, so this would have to be minus 4. 9 plus minus 4 is 5, or require 7 more. And that means that 8 works. It's the smallest possible value of x, so we have our answer. Okay. Steph scored 15 out of 20 attempts in the first half of the game and 10 out of 10 in the second half. Candace took 12 attempts in the first half and 18 in the second. In each half, Steph scored a higher percentage of baskets than Candace. Surprisingly, they ended with the same overall percentage of baskets scored. How many more baskets did Candace score in the second half than the first? So, since they each took 30 shots in total, that means they also made the same amount of baskets. Steph made 25, Candace must have also made 25. Now, in the second half, Steph made 10 out of 10, which is 100%. And that means, and since Candace made fewer than that, we know that she made at most 17. Could be anything under 17. Now, Steph made 15 out of 20 in the first half, which is 75%. That means Candace made under 75%. 75% of 12 is 9, so we know she made at most 8. Now, although both of these numbers are sort of like the at most case, they add up to 25, which is the number that we need. So we can't actually lower any of these numbers, meaning that these are the numbers we're looking for. We want to know how many more baskets Candace scored in the second half than the first. So 17 minus 8, we have 9. A bus takes 2 minutes from one stop to the next and waits 1 minute at each stop to let passengers board. Zia takes 5 minutes to walk from one bus stop to the next. As Zia reaches a bus stop, if the bus is at the previous stop or has already left the previous stop, she will then wait for the bus. Otherwise, she will start walking towards the next stop. Suppose the bus and Zia start at the same time toward the library with the bus 3 stops behind. After how many minutes will Zia board the bus? Okay, let's think about this. I'm going to use this white space down here. Each of these dots will represent a bus stop. Now let's say Zia starts here, which is 3 stops ahead of the bus. And we also need to draw more stops. So at the start, Zia is going to start walking forward. After 5 minutes, she reaches the next stop, and the bus has traveled 2 minutes, waited 1 minute, and traveled 2 more minutes. Now, since Zia is here at this stop and the bus is not within 1 stop, she's going to continue walking for another 5 minutes. Now, in these 5 minutes, the bus is going to wait 1 minute at this stop, travel 2 minutes, wait 1 minute, and travel halfway to the next stop. Now, Zia still doesn't see the bus, within 1 stop, so she's going to walk another 5 minutes. In that 5 minutes, the bus finishes the 1 minute drive, waits 1 minute, drives 2 minutes, and waits 1 minute. Now, at this point, Zia sees that the bus is at the previous stop, so she's going to wait. So after 2 more minutes, the bus will reach and she'll get on. So in total, she's spent 5 minutes, 5 minutes, 5 minutes, and spent 2 minutes waiting. It's a total of 17 minutes. Problem 23. A triangle or circle is placed in each of the 9 squares in a 3x3 grid. Shown below is a sample configuration with 3 triangles in a line. How many configurations will have 3 triangles in a line and 3 circles in a line? So, 3 triangles and 3 circles in a line. So if we think about how many ways there are to put these in a line, if we try to use the diagonal, we run into a problem because it's not possible to have 3, one diagonal have 3 triangles, for example, and also have 3 circles. So we're only going to be looking at rows and columns. So let's start with the columns case. If we have this one column of triangles and another column of circles, then how many ways are there to do this? Well, we have 3 places, 3 columns to choose for the triangle column, then 2 for the circle column, and then for the remaining 3 spots, each of those has 2 possibilities. So we have 2 cubed, but we don't want it to be 3 circles or 3 triangles because that would result in double counting. We need this to be a unique case. So this would give us 36. And now we can go back and count the cases where the 3 happen to be the same. Because in that case, if there were 3 circles, for example, now we have a triangle column and 2 circle columns, which is just 3 cases. And 3 cases for the flip, if there's 1 circle column and 2 triangle columns. That gives us 42. And we also need to consider the rows case, which is symmetrical to the columns case, which means that our answer is just double 42, or 84. The figure below shows a polygon consisting of rectangles and right triangles. When cut out and folded on the dotted lines, the polygons form a triangular prism. Suppose that AH equals EF equals 8 and GH equals 14. What is the volume of the prism? So let's see what we've got. EF is 8, H is 8, GH is 14. Okay. If you imagine folding this prism, EF is going to get folded, like this rectangle will get folded upwards first, and then when this dotted line gets folded, CF, the rectangle will end up landing on FG. So that means that this also has to be 8. And now in this triangular prism, the formula for the volume of the triangular prism is going to be the area of the triangle times the width. And we have our width already, which is 8. All we need now is the area of the triangle. We have one side of the triangle from AH, since AH must equal BJ given this rectangle. And we also have this side length of 14, which should be helpful. What else are we given? Okay, again, BC must be equal to GF, since that's a rectangle. And once we fold the prism, AB is going to land on BC, meaning that AB also must be 8. And HJ must also be 8, since we have a square actually here. Given this side length of 14, we know that JG is 6, it's the remainder. And now we just need to find the area of this right triangle here. And that's base times height divided by 2. That's 24. And so now we just need 24 times 8, which is C, 192. Problem 25. A cricket randomly hops between 4 leaves, on each turn hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? So, after the first hop, there's a 0% chance of being on the leaf it started, because it must be on a different leaf. Now, after 2 hops, the probability that it goes from the leaf it was on back to the original is just 1/3. After 3 hops. So there's a 1/3 chance it was on the leaf it just started on, in which case it definitely jumped to a different leaf. However, there's a 2/3 chance it was still on a different leaf, and there's a 1/3 chance that it would jump from that different leaf back to the original. So that 2/3 gets multiplied by 1/3, so we have a 2/9 chance of being on its original leaf now. For the final leap, if it is on its original leaf after 3, there's no way it can end on its original after 4. However, there's a 7/9 chance that it wasn't on the original leaf, and in that case, there's a 1/3 chance of jumping back to the original. So it's 7/9 times 1/3, which gives us 7/27. And there's the answer, E. So those were all the problems from the 2022 AMC 8. Any questions? Let me check the chat. Okay, if there are no questions, then I'm going to end the meeting here. And thank you for coming. Oh. Yeah, no problem. Thanks for coming. Bye.